we now come to the part where we will learn how to find the angle between two planes. Now this part of the lesson, I think is best to show you using an example. Rather than I teach you and then I show you an example, I rather we can just learn straight away from the example. Now let's look at this question. Find the angle between, acute angle between these two planes given in its Cartesian form. Now let's look at these two planes. Let's call this the first plane, and this is given as, now I rewrite this in the form of a scalar product because we need to use this normal. So the scalar product will be given in the form of r dot. Now the coefficient of x, y, z will be the ijk component of the normal. So you have 2, minus 3, and 4, and over here you have 5. Now how about this one? This one will, in the same way, this will be equals to r dot 3, 5, minus 2, and then you have 7 here. Now let's look at this. Okay, now this is the normal of plane 2. Let's call this 1. Now this is the normal of plane 2. N2 is the normal of plane 2. Now so this is 90 degree because it's a normal. Now for plane 1, the normal is N1. So this is 90 degree as well. Now if the angle between, they have two angles between two planes. One is a theta, alright. The other one will be 180 minus theta. Alright. There's two possible angle between two planes. It depends on which one are you looking for. Alright. The difference is 180 degrees. If one of them is theta, the other one will be 180 minus theta. Now if this is theta, what is this angle over here? Now this angle, because this 2 is 90. Alright, so angle in a four-sided figure is 360. These two angles add up to 180, and this is theta. So altogether will be 360. This angle will be 360 minus 180 minus theta. So this angle will be 180 minus theta. Alright. Now so how to find this angle? Okay. Now this angle you learn in the dot product. Okay. So you take unit vector n1 dot n2. Okay. And then you will get the angle between them. Okay. So in this case it's 180 minus theta, but actually it doesn't matter because if I call this theta, then this will be 180 minus theta. Alright, if I call this theta, then this will be 180 minus theta. Alright, then this is theta. Now let me just maybe I call the angle okay, I just use cos 180 minus theta. So what is the unit vector of n1? It will be n1 is 2 minus 3, 4. Now I have to divide it by its magnitude in order to change it to its unit vector. What will I get for this? Now this will be 4. 2 square is 4 plus 3 square is 9. 4 square is 16. Now then dot the unit vector n2. This will be 3, 5 minus 2. Now in order to make it a unit vector, I have to divide by its magnitude again. So 1 over square root of 9 plus 25 plus 4. Okay. Now if I do a dot product, what will I get? Now here I will get 6. Then I will get minus 15. Now actually I need to, okay, doesn't, sorry. This will be 6 and then this will be minus 18 and then over here is minus 8. Okay. Then this will be square root of 29 into square root of 49. Okay. Now what will I get for this? Over here I will get minus 17 over square root of 29 into square root of 49, or square root of 49 is 7. So 180 minus theta will be equals to cos inverse of minus 17 over square root of 29 square root of 49. And then if I use a calculator, I will get 0.8 degrees. Alright, this one I just cancel it out. Okay, 120.8 degrees. That is for this angle over here. Now you see, if this angle is obtuse, they look for acute, right? You just need to use 180 minus the obtuse angle. All right, because when we draw, we do not know actually is whether it's acute or whether it's obtuse. So I just draw for you. Now once you find that it is obtuse, the acute angle is just 180 minus this. All right, look at this diagram. If this is theta, this will be 180 minus theta. All right, if I call this 180 minus theta, then this side will be theta. So the angle between them, the required angle will be theta equals to 180 degrees minus 120.8 degrees. All right, what will you get? You will get 59.2 degrees. Okay, this is the required angle.